Okay, so members, welcome to this lesson. Let us see how do we handle now when they are giving you some volumes and then they're asking you the height of a similar shape. Please don't forget to subscribe to the channel. Okay, let us go through the first. A beaker of height 21 centimeters has a volume of 135. Find the height of a similar beaker whose volume is 40. That's what they are giving. We have length related to a volume. I know that the only formula that does that is always the volume scale factor is equal to linear scale factor cubed. So if now I know the volume of that, this is going to be the big volume. So it's going to be now 135 over the volume of S1 is 40. Then this one. Now, this one, the corresponding length of this one and this volume is 21 over x, the whole cubed. Now, I can substitute I can cross multiply and get my answer. So, this will be now 135 equaling to 21 cubed over x cubed, the whole over 40. So if I cross multiply here, is that x cubed, then times 21 whole cubed. So if I run it right here, but now my x cubed is going to be 40 times 21 cubed, the whole over 135. So my x cubed is going to be 744. Getting the cube root, your x will be the cube root of 2744. And so my x is going to be, so here I'm having 14 centimeters. So meaning the volume of the beaker with 40 is going to be that. Here, the area, a rectangle 6 centimeters long and 5 centimeters wide is enlarged so that its area becomes 270. Find the linear scale factor. Here the idea is very easy. The solution here, now we are dealing with areas. So now, the area scale factor is given by the big area over the small area. Now, we know that area scale factor is also given as linear scale factor squared. So now, can you get the area scale factor? The area scale factor. Now, we know the big area is given. Now we need the small area, because if you enlarge it, this is going to be the big area. Now we need the small area. So the big area is the one when we enlarge, which is 270. Then the small area is going to be the one before it was enlarged, which is 6 times the area of this rectangle, 5, which will be 30. Meaning that now my area scale factor will be equal to now 270 over 30. But the whole of this is going to be equal to the linear scale factor squared. So it's like this is 0. So when it's that we are getting 9. So 9 is equal to LXF squared. And so that now our root of 9 will be equal to our linear scale factor. Our linear scale factor now is going to be 3. We don't have units. So, heights, of course it's plus or minus, but because it was enlarged, the scale factor is positive. Heights of two similar things are this and this respectively. If the volume of the larger thing is this, find the volume of the small thing. Now so we have heights and then the volume. So what formula do we have that relates the two? That corrects our volume scale factor The length with the line, I mean the sides, is that. So we have this volume. We want the other volume of the small thing. So we say, let volume of small thing be y. So now, I'm going to be adding there for the larger volume. B, the big volume, over the small volume, which is y. We'll be equal to the linear scale factor. How do you get the linear scale factor? We get a big line, which is two similar things. Of course, this one is going to be adding the big height over the small height, but this time the whole cubed. So this will be now 405y equaling to 15 cubed over 10 cubed. This part goes to this and this. So if you want to make y the sum, this is that we shall cross multiply. So 45 times 10, the whole cubed will be y times now 15 cubed. And so here my y will be this 405 times this cubed is 1000 over 15 cubed, and you get your y as so the answer here I'm getting is 120 cubic centimeters. And so that's the volume of the other small tin. So that's it, members. Unless you have a question, I want to wish you the best. Okay, so that's all, members. Unless you have a question, you can leave it in the comment section.